Okay, so in hydrocarbons chapter, first thing is that what are we going to study? है ना? So in hydrocarbons, we are going to study 4 things. Okay, we'll be studying about alkane. Acha, one more thing, you don't have to write this. Okay, you don't have to write whatever I am writing this here. I will send you the PDF. Alkane, alkene, alkyne, and aromatic compounds. Okay, and aromatic compounds. So these are the 4 things that we have to study. Now, alkane, alkene, and alkyne. You can take this as a bunch because all of these are simple hydrocarbons, and then we'll be studying like the way or the topics that we are going to study in aromatics. It will be slightly different from alkene, alkene, and alkyne. For all of these, we will be studying about preparation. We'll be studying before preparation. We'll be studying about the structure and a general introduction of alkene, alkene, and alkyne. For each of them, we will do after the general introduction. We will talk about the structure. Then after that, we will talk about the physical properties. Okay, then methods of preparation. Okay, and then we will talk about the chemical properties. Okay, so when we are learning about structure, then here we will also learn about isomerism in all of them. The way of studying and the subtopics of aromatic compounds, it will be slightly different than alkene, alkene, and alkyne. Okay, so with this, we will start first of all what? We'll start alkanes. Okay, we'll start alkanes. So write the topic. No, don't write the topic. Don't write the topic. Alkane. Right, alkane. So these are saturated hydrocarbons. You know these things from your 10th standard only. Saturated hydrocarbons that contains only carbon-carbon bonds, which those carbon-carbon bonds are single bonds. Okay, carbon-carbon single bonds. Okay, so there is no carbon-carbon double bond. These are also known as AKA. These are also known as paraffins. Paraffins. So paraffins is derived from 2 letters. One is param. Param means little, and affins. Affins means it is derived from affinity. Okay, that means it has little affinity, which means it has low chemical reactivity. And this name is derived from its property, low chemical reactivity. So alkanes, they don't react very easily with different molecules and atoms. I can divide alkanes into 2 parts. I can divide alkane into major 2 types: open chain, which has the formula CnH2n plus 2, and there is another one which is closed chain or cyclic alkenes. Closed chain. The formula for this is general formula is CnH2n. CnH2n. Okay. So open chain may we have examples such as CH4, which is methane, C2H6, ethane. Okay. And in closed chain, you have structures such as cyclopropane, cyclobutane, cyclopentane, and cyclohexane. So these are the closed chain structures. So I hope you have already seen all of these parts, all of these things. Yes or no, guys? Tell me.
Yes, sir.
Yes, all of you have seen this type of things, right? All of. Next is right. Next, the structure of Structure of alkane. So when we write structure of alkane, we mean the structure of carbon atom that is present in alkane. So even if I have pentane, or if I have hexane, or if I have a simple propane, so what I am talking about is the structure of this carbon atom, or this carbon atom, or this carbon atom, or this carbon atom. So all alkanes, okay, all alkanes, the carbon in all of the alkanes, they will have similar kind of structure. And by structure I mean according to the electronic geometry and the shape and the bond angles. So we have the steric number here is how much, because we have carbon which is having 4 bonds. All 4 bonds are single bonds. So steric number will be equal to 4. The hybridization will be equal to sp3, right? And the geometry will be tetrahedral. चैप्टर 4 भाई आप लोग को याद नहीं है ये सब, भूल गए? Tetrahedral. Shape will also be tetrahedral. Bond angle 109.5 degrees. 109.5 degrees. Okay. Now this, if I talk about the 3D structure, then carbon is, there are 2 bonds like this. There is a bond, and there is another bond which is back, which is at the back. Okay, one bond it is at the back. These 2 bonds are in the plane, and then you have this bond which is out of the plane. That means it is backwards, and this is coming forwards. Achha, let me just show you. Have I shown you the CH4 molecule, the structure? No or yes? No.
I guess yes.
You guess yes? Okay. बाकी लोग को नहीं याद?
Like we have seen the structure, like the geometry of tetrahedral and the shape.
Geometry of tetrahedral. अच्छा, वो Avogadro software में दिखाया था हमने?
Yes.
अच्छा, okay, fine. No, so this is the thing. If you can you see this now?
Yes, sir.
No. So this is how I have written it. This is how I have written it. So this carbon atom, sorry, this hydrogen atom, then carbon, this carbon. So all of them are in the same plane, and this hydrogen is coming outwards, and the other carbon is going backwards. Okay, the other carbon is going backwards. Now this will be true even if I increase the number of carbon atoms. Okay, so let me say that I'm increasing the number of carbon atoms, and I need to optimize this thing. Okay. Now, if I look at any carbon atom, let us say this carbon atom here. So if I look at this carbon atom, then in this carbon atom, I can say this carbon, and this carbon. These are in one plane, right? These are in one plane. Okay, these are in one plane. This hydrogen atom, one of the bonds, it will be coming outside, and there will be another bond which will be behind the screen, Okay, so we have 4 bonds. Two of those bonds are on the same plane, and the one bond is behind the screen, the other bond is coming outwards the screen. Okay, so this is this dark line, which represents that this bond is coming away from the screen, and this dashed line, it represents that it is going behind the screen. Okay, this is the structure actual. Okay, now let us just start revising the IUPAC nomenclature. So write this question. Questions लिखना पड़ेगा आपको, notes नहीं, है ना? Just write the questions.
Sir, do we have to write the names in the chat box?
No need of that.
Okay.
Let me know, but let me know if you're done, okay? ऐसा नहीं कि चुपचाप बैठे रह गए आप लोग. फर्स्ट हुआ किसी का? अरे फर्स्ट नहीं हुआ किसी का अभी तक. What happened, guys? I hope you are making the correct structure first of all. So here we have CS. Okay, first of all, what you will do, you will first of all write these parts. Okay, so write it like this: carbon, CH2, carbon. Okay, carbon, CH2, and you have carbon. So after writing these things, you will see that this first carbon atom, it is attached to CH3. And how many CH3s? 3 CH3s. This carbon atom is also attached to 3 CH3s. Okay, now you write the functional group, unsat, parent, and substituents. Functional group is E and saturation is AN. What is the parent, guys? Parent बताइए क्या है? What is the parent?
And
Methyl. Oh, sorry, pen.
कितना क्या बोला था आपने खालिद?
No, sir, I accidentally said for sub.
Substituents, okay. है ना? And then we have the substituents. These are the substituents. So all of the substituents are methyl, and how many methyl? 4 methyl. So tetramethyl. Tetramethyl. And if I want to number it, I can number start from here 1, 2, 3, 4, and 5. So here we have at 2, 2, 4, 4. है ना? So tetra 4 methyl. So you should have at least 4 numbers. Then you write the name as 2, 2, 4, 4, tetramethyl. Pentane. ठीक है? What about the second question? You have only one carbon atom. So write the carbon atom like this. Then you have 2 CH3 groups attached. And here you have 2 C2H5 groups attached. Okay, 2 CH3 and you have 2 CH. Okay. CH3, CH3. C2H5, that means CH2, CH3, CH2, CH3. Okay. So now write this and tell me what is the parent. बाकी सब तो same होगा. Tell me what is the parent here. Terminal to terminal है ना? Please remember those things, small things. To start from terminal, end with terminal. If you don't have functional group unsaturation or any subsequent functional group unsaturation, then you will choose the longest chain, right? If you don't have any functional group or double bond or triple bond, then you are going to choose the longest chain.
Sir, bute.
बताइए. A, B, C, D. कहाँ से start करें हमजा? हम बताइए.
Sir,
कहाँ से
A,
start करें?
like start from anywhere.
Anywhere? No.
I mean,
nothing.
not anywhere. Like you can start from B, A, or D.
B or D? नहीं. No. No. I can only start from D or C, not A or B. है ना? All of these carbons are not same. You will start from a terminal which is most away from the junction. है ना? ये junction है यहाँ पे, जैसे सबसे बाहर जाके यहाँ पे ये कार्बन से start कीजिए आप. Then only you will be getting most number of carbon atoms, right? Pent, है कि नहीं?
Yes, sir.
So it will be methyl and methyl, 2 methyls. So 1, 2, 3, 4, and 5, or 1, 2, 3, yeah, same thing. So we'll have 3, 3 dimethyl. Pentane. Okay. Question लिख लिया आपने? Or if you have written the question, na?
Yes, sir.
Okay. Then we have tetra tert butyl methane. Third is tetra tert butyl methane. So we have meth, that means 1 carbon atom, and it has tetra tert butyl. So I hope you all remember what is tert butyl. This group, yes or no? The point of attachment here is at the third carbon atom, sorry, 3-degree carbon atom, that is tertiary carbon atom. You remember this, yes or no? Tell me. Tert butyl, sec butyl, isobutyl.
Yes, sir.
है ना? Okay. So this is tetra tert butyl. Tetra tert butyl means this carbon has tert butyl group attached, and how many? 4 third butyl group attached. So we will write carbon, CH3, 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 carbon. You can also write Me instead of CH3, है ना? I hope you guys remember these things. अब बताइए पेरेंट. Just choose the parent, okay? What happened? Parent, guys.
Well,
Okay, what about others? Hamza, Hiba, Salman.
Yes, sir. Pent, I guess.
And all of you, na? Okay, fine. Good. Right, start because now see all of these carbon atoms are same, है ना? कैसे? देखिए, हम यहाँ से start करें तभी we get junction in one bond. If I start from here, then also I get junction in one bond. If I start from here, then also I get junction in one bond. है ना? Same with all of these things. I'm getting junction at one bond only. Okay, and then the next junction, if I start from any of them, the next junction is where the next junction is again at the next carbon atom. From here also it is in the next carbon atom. Here also it is one of the next carbon atom. Okay, and here also from the next carbon atom. So all of these are same carbon atoms. So I can start from anywhere. But if you look here, you can see here, right, Hamza, why this carbon atom is different from these two carbon atoms. Yes or no?
Yes, sir.
है ना? So that means I can, in this case, I can start from anywhere. I will just have to keep in mind the junction. So the junction is here, so I will move rightwards because I can see more number of carbon atoms here also. I can move anywhere, top or bottom also rightwards. So just to go with the flow, I'm moving this direction, and here also I can move anywhere. CS3. So I can see that I have some. So these are my substituents. So these are the methyl substituents, and then I have, this is my third butyl substituent. These are my third butyl substituents. Okay. So if I start numbering 1, 2, 3, 4, 5. So substituent may we have 2, 2, then 4, 4. We have tetramethyl, and the substituent is 3, 3, di-third butyl. So we have butyl here and we have methyl here. So B will come first. So we will write first of all 3, 3, 3, 3 di third butyl, followed by 2, 2, 4, 4 tetramethyl, pentane. Okay, so write this down. Let me know if you are done. No, don't write this down. Don't let me know if you are done. All of you understood this now? Yes or no?
Yes, sir.
Okay, fine. Right, next, isomerism in alkane. Don't write next, isomerism in alkane. Isomerism in alkane. Isomerism in alkane. First, alkanes show chain isomerism. You remember chain isomerism? Or don't remember? Guys, tell me. Chain isomerism याद है आप लोगों को? नहीं याद है? नहीं याद है?
Yes, sir. Yes, sir. I remember.
नाम याद है बस, isomers with.
No, I remember that. Like I just tried to remember it and I got it.
You got it. What is this? Isomers. What is different here? In chain isomer, what is different? With different chain lengths, na? The chain length is different. Yes or no?
Yes, sir.
Okay. Chain length is different. So if you have CH4, then obviously you cannot have chain length because there is not even a chain, right? You just have only one carbon atom. So CH4 will not show any. CH4 will not show any type of chain isomerism or any isomerism. Then if I move to the next carbon atom, next alkane in the series, we have C2H6, which is CH3 bonded to CH3. Now this also cannot have any. We have only one link here. Okay, one link here. So ऐसा chain जो होता है उसमें क्या होता है? If you have only one kadi, right? If you have only one kadi, then you can't do anything, right? There is only one way of writing this molecule, or there is only one way of arranging this particular chain. There's only one way. So ethane also does not have any chain isomerism. If I move forward, CH3, CH2, CH3. So the way you can look at this is you have, okay, now you have two kadi, है ना? कड़ी को क्या बोलते हैं यार हिंदी में? Does anyone know? हिंदी में बोल रहे हैं, इंग्लिश में क्या बोलते हैं कड़ी को? You know chain, Hamza, Hiba, you can help me
Yes,
better, I
sir.
think. Chain में कड़ी होती है.
Yes, sir.
What is that one kadi called in English? Do you know that? Link.
I don't know.
Link.
I mean, I'm not sure about that.
You have not heard about? अरे नहीं, chain it means simple chain, right? सिक्कड़ जो होता है ना. Okay, fine. Don't bother. So in this also, this way we can also arrange it in one other way, which is like this. Correct. But again, what I'm writing is CH3, CH2, CH3. So it is again propane. It is not a different structure. So even if we have 3 carbon atoms, so all of this will not have any chain isomer. Okay, it's methane, ethane, and propane. They don't have any chain isomerism. Now we have butane, which has chain isomerism. So write butane. No, don't write. No. So CH3, CH2, CH2, CH3. Now we have 3 links, right? Now we have 3 links here. Now what I can do, I can shorten this link to 2 links, and then 1 link will be in middle. And if I try to write this will be CH3, CH, CH3, and CH3. Okay. So if you calculate the formula, both of them will have the same molecular formula, but this will be butane, simple butane. And what will be this? This will be 2-methyl propane. So if you look here, we have difference in the chain but prop. So the parent chain length, main chain length is different, and that is why these are known as chain isomers. These are known as chain isomers. Next, obviously, if butane has some chain isomerism, pentane will also show chain isomerism. So next we will look at pentane. So CH3, CH2, 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 and CH3. So we have 1, 2, 3, 4, and 5. So obviously I can reduce the chain length. I can write 1, 2, 3, 4, and I can put one of the carbons here. Now to represent that, I will write CH2, CH3, CH2, CH, CH3, and here I will get a CH3 carbon, and this will be one of the isomers. This will be one of the isomers. So we are just rearranging the carbon atoms. Okay. Now you can also say that I can move this carbon atom here, but please remember that both of these structures are same. It is just that we have looking this at this. We are looking at this from a different perspective. So if I just flip this up, then you can see both of these things are same, right? Yes or no? See?
Yes, sir.
This structure, these structures are same only. Okay. So that is why. Now pentane, we have done 2. We can also reduce the chain length once more and put one of the carbon atoms here, one of the carbon atoms here. So we'll get CH3, one carbon atom here. Then we'll have CH3, 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 and CH3. You can write the names for this also. Moving on to hexane. Hexane. So I will start with CH3, CH2, 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 and one more CH3. 3, 4, 5, and 6 carbon atoms. So first of all, I will shorten this to 5 carbon atoms. 2, 3, 4, right? 5. 5 carbon atoms happen. Then I will write one CH3 here. Then I can also shift this 1, 2, 3, 4, 5. And if I write one carbon atom here, that means both of these things are different. So 1, 2, and 3, right? 2 and 3 are different. Now I can reduce once more. 2, 3, 4. Yeah, 4. Now I can write 2 structures here. I can either keep both the carbon atoms, 4 carbons to 5th carbon here, 6th carbon here in the same carbon atom, or I can do something like this. 1, 2, 3, 4. One carbon atom should be here. The other carbon atom should be here. This is 4th and this is 5th. Now, if you try to reduce once more, 2, 3, right? Now, what you can do, there is only one option. You can either put one carbon here and the 2 other carbons here. But again, if you look at this structure, then this structure is similar to the 4th structure that we have made. 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons, and the second carbon has 2 methyl groups attached. Okay, so that means we cannot go any further down than 5. We cannot go more than 5. So hexane has 5 isomers. So you will write the names here. Okay, you'll write the names here. You'll write structure and then you will write also the names. Okay, so I have drawn this like this, like kind of a bond line structure. You will have to write the name. Now, if I want to write for alkanes, So let me write it like this. Alkane, and rather than alkane, I'm writing the number of carbon atoms. Okay, alkane. Hash means number of carbon atoms, and here is the isomers. If the alkane contains one carbon atom, there is 0 isomer. If there is 2 carbon atom in alkane, that means also 0. If you have 3, then also 0. If you have 4 carbon atoms, then you will get 2 isomers. For 5, you get how much? 3. For 6, you get 5. And then for 7, you get 9. For 8, you get 18. If you have 9 carbon atoms, then you get 35. If you have 10 carbon atoms, you will get 75 isomers. Okay, for 10 carbon atom, 75. Okay, right. Now, you remember 1 degree, 2 degree, 3 degree, 4 degree? Guys, tell me.
Yes, sir.
All of you? Yes, Salman, Khalid?
Yes,
Nahi
sir.
hai.
Yes, sir.
Okay, so that's what we are going to. So just to keep that in your notes, I'm writing the topic. Classification. Classification of carbon atoms in alkane. Okay, classification of carbon atom in alkane. So you know that if a carbon atom, carbon attached to only one carbon, this is known as 1 degree or primary. This will be primary carbon. Carbon attached to 2 carbons, this will be 2 degree, or we also call this secondary carbon. We have carbon attached to 3 carbons, then it is 3 degree, or tertiary carbon. If you have carbon attached to 4 carbon, it is known as 4 degree or quaternary. Okay, so 1 carbon, then 1 degree, 2 carbon, then 2 degree, 3 carbon, then 3 degree, 4 carbon, then 4 degree. Fine. Now I will write some questions. You will tell me. What is the degree of carbon atoms in all of them. Okay. So the question would be assign the, I can say assign 1 degree, 2 degree, 3 degree, 4 degree to each carbon in following.
Sir, what is the name of the 4 degree again?
Quaternary.
Okay.
CH3 carbon, CH3 H, CH2, okay. Chalo. Write these 3 questions, है ना? So in A and C, you will have to write 1 degree, 2 degree for all of the carbon atoms that are present. Okay, but in the B1, you just write for A, B, C, D, E, F. You don't have to write for the others. Okay, Salman has sent me for the B1. Salman, can you please recheck for B and F?
Yeah, yes, sir.
Or carbon labeled as B and the carbon labeled as F.
Okay, let me. Oh, yeah, okay.
What about others, guys? Khalid, Hamza, Hiba.
Just sending it.
Okay, okay. Hamza, can you check for D and F also? चेक फॉर डी, नहीं डी तो ठीक है आपका, भी ठीक है, नहीं डी डी डी, हाँ डी और एफ, डी और एफ, सॉरी हमसा, चेक फॉर डी और एफ, डी एंड एफ, ओके खालिद, ओके खालिद, check for B, C is fine, D is fine, E is fine, F, check for F, check for B and F. Okay. Yes, Hamza, correct. What about Hiba? I'm waiting for you. I hope you have done for the A1 also. So let me just write the answers for the A1. 1 degree, 3 degree, 1 degree, 2 degree, 4 degree, 1 degree, 1 degree, 1 degree. For this one we have 1 degree, 4 degree, 1 degree, 1 degree, 2 degree, and 1 degree. Hiba, I'm waiting for your answer. Are you done, Hiba? Hiba, can you tell me if you're done? Then you can just tell me the answers for A, B, C, D, E, F. No need to write in the chat.
Yes, sir, done.
हाँ बताइए फिर A के लिए क्या है बताइए. A is
1 degree.
ये A है ना? Yes, हिबा.
1 degree.
हिबा ये तो कार्बन एटम्स लगे हैं ना इसमें, इधर भी कार्बन है, इधर भी कार्बन है, क्या हो गया है? व्हाट आर दीस हिबा? ये जो लाइन बनाया हमने, ये क्या है? यस हिबा.
I didn't see that.
देखा ही नहीं आपने. बी बताइए फिर, बी बताइए, बी बताइए.
2 degree.
2 डिग्री. सी बताइए.
3 degree.
3. डी
3 degree.
3 डिग्री. एंड ई
1 degree.
1 डिग्री. एफ
2 degree.
2 डिग्री. ए हो जाएगा 4 डिग्री, है ना?
Yes, sir.
Right, okay, fine, chalo. So this is it for today, and Thursday you will have the lecture an hour before, है ना? एक ही घंटे का होगा, not 2 hours. You will have the lecture for 1 hour, but it will be, the slot has been changed and it has been preponed, है ना? 1 घंटा पहले होगा. And you
1 hour.
1 hour होगा, हाँ 1 hour.
Oh, okay. I thought 2 hours straight.
नहीं नहीं नहीं, तो निष्कर्ष सर ने पूछा होगा ना आप लोगों से, तो आज 2 घंटे.
Yeah, he did.
हाँ, तो आप लोगों ने शायद मना कर दिया. नहीं नहीं मना किया, मना कर दिया, पता नहीं. खैर हाँ
He
ठीक है,
just
कोई बात नहीं. हाँ
changed the time. He didn't ask.
Yes, to me also. Like he didn't ask. He
He
said
was like
from 6:30
30
to 8:30.
8:30. Then he was like later 7:30 to 8:30.
अच्छा, he sent you the time. हाँ
Yeah, he did
Yes, sir.
today, and then he was like, "No, don't come that time. Come later."
अच्छा, come later. Okay, fine. Then actually, see, what I was planning that we can merge 2 batches because same topics are going on. Okay, and here also we have 4 5 students. There also we have 4 5 students. So the limit is of like 9 10 students we have to keep, na.